Hi, everybody. Today's September 12th, 2023, and I am honored to have with me Professor Dr. Matthew Wielicki. Tell us about your journey of late.
I have a PhD in geochemistry from UCLA, and I postdoced at UCLA for a few years, and then took a faculty position at the University of Alabama in earth science. My research is primarily in early Earth and aspects of the Hadean eon, which is like the first 500 million years of the Earth's history. And that's a time period that's really interesting because we think that's the origin of life and oceans develop. And so our modern planet is really shaped at that time. But I started to notice and kind of observe that my students were having a lot of anxiety in terms of climate and around climate change. And I started to speak up a little bit about it. I felt like I could take an objective opinion about climate because I have the expertise in the earth sciences, and the isotope geochemistry is one of the ways, it's the predominant proxy that we use for understanding climate science. And so my funding wasn't anywhere near it. So I could take objective views. I knew I wouldn't get in trouble because I wasn't publishing in that community. And so I started speaking up about climate quite a bit. And I noticed a huge backlash in academia. This was one of these topics that you really couldn't speak out against, even if you're asking honest questions and bringing up peer-reviewed literature and trying to make connections that maybe the media is not making. And so a lot of the other climate scientists were staying quiet, even though in the back channels they would talk about it. So I started speaking out against that a little bit more. And since then, I've left my position in academia and moved states. There was a lot of reasons for that. And now I've been publishing on Substack and mainly just kind of musing about science and culture and politics. And
some great stuff, and I applaud you on that. A, for the bravery, or lunacy.
One or the other.
Yeah, sometimes they go hand in hand. What is it, A Beautiful Mind or something like that?
That's right.
You remember that?
Yes.
Movie? So I'm going to just pop up maybe a couple pictures from your Substack.
Sure.
So this one's a little too big, I guess. So life without oil, not as simple as you may think. You also have a more recent set of articles here. This is your Substack, Irrational Fear. So the title somewhat speaks for itself. And you're examining the most newsworthy climate papers of the last decade, marine heat waves, natural disasters. I actually have read a number of these. I have them kind of listed up here, but we maybe can come to that a little bit. The ones that kind of caught my eye was you had one about, obscurely enough, about Southwest Asia and heat problems there. Can you talk about the general gist of the paper? I'll try to pull it up in the meanwhile.
Yeah, sure. So what I've been doing is there's what I think is a pretty good website, Carbon Brief, and they do a lot of good analysis on how media and climate papers interact. And one thing that they do is they publish these kind of top climate papers, top 10 climate papers every year. So this was, I think, in 2015. And so the top newsworthy paper, although they put some metrics to it, so it ends up being number 5 to them. But I went by the most news articles published. So this was in 2014. The most news article published was about this heat that was going to come, and you can see it there. It's number 4 for them. And so the first column is their metric score, or the first kind of half circle score is their metric score. The second half circle is the number of news articles. So that number 4 one gets 122 news articles. So that's the one I chose as the most, I would claim that's the most newsworthy article for that year because it had the most news articles. So I'm not taking exactly their metric because they looked at social media as well. But that article talks about what's now becoming a new common discussion, which is wet globe temperatures. This is something that I talk about in another one of my articles. But this is a new metric that has been developed that actually is really good. It's a good way to talk about how the human body is interacting with the temperature, because it takes into account humidity. And if you've ever lived in Alabama, for example, where I used to be, you know that humidity is a huge driver in terms of how hot it feels, right? If it's 85 degrees in Denver, where I am now, and it's 25% humidity, it feels great. I'm out playing golf. I don't really mind it. Maybe I'm sweating a little bit. But if it's 85 in Alabama and it's 85% humidity, I'm drenched, right? So these are these wet globe temperatures. The problem with wet globe temperatures is that we don't have the numbers for these back in the time periods where we have really good data on massive heat waves, for example, the 30s in the United States. And so this is difficult to kind of compare these. So what I said was, okay, well, I can't really make a comparison to wet globe temperatures in the past, but what I can do is say, okay, this paper came out in 2015. We've had 9 years since that paper came out. The paper claims that the temperatures due to climate change are going to make this region uninhabitable for humans. And so let's just take a look at how the population has changed since the paper was published. And if we look at how the population of that area has changed, unfortunately, there's a few war-torn countries like Syria that there have been declines in population. But any other region in that, in the region that they claim, so that's what you just pulled up is a figure from the paper, the vast majority of those nations continue to have rapid population increases. And you can just see that. And what's interesting is notice that those curves, all of them really reach their steepest point around 1975-ish, somewhere between 1960 and 1980. It appears that those curves are all really kind of ramping up. And if you scroll down just a little bit more, that coincides directly to the time period that the NOAA GISS database suggests was heating the fastest, right? So that's when we're ramping up our heating the most. And so it's just clear that warmth has always been a driver for increased population, for increased wealth, for increased growth, and cold tends to do the exact opposite. We can see the Little Ice Age, for example, that had huge detrimental effects to crop yields and to disease in the Northern Hemisphere. And so, these claims that this extra few degrees of warming that people expect is going to make this land uninhabitable just isn't supported by the data. If we look at the first 1 degree of warming that we've already had, that seems to be driving the population to these areas. These populations are increasing rapidly. And so, these are just these hyperbolic claims that the news media loves to clam onto, and it really pushes. And then, young scientists like I used to be see that, and they say, well, I want to make a splash. I want to get that newsworthy article. I'm going to write something that's a little hyperbolic. And then that's going to get me, I'm going to put all that news media that I got into my next funding grant. And then I'm going to write something even more hyperbolic, even though the science doesn't really support this. There's this huge gear and this machine that's pushing these young researchers into making these more and more absurd statements. And now that we've had 10 or so years that this great website, Carbon Brief, has been doing this, I'm just going back and comparing the 9 years or 10 years of data since they've been published, these papers have been published, and whether any of their predictions are holding true. And you can just clearly see that they're not.
Well, that doesn't seem fair of you, does it?
Yeah, that's very unfair.
Yeah.
That makes me a denier.
Yeah, no, I personally like to make predictions about the NFL, and I like to talk about who's going to win the Super Bowl 10 years from now and so forth. But what I really hate is when people point out that I was wrong.
Yeah. It's hindsight is actually 2020. And if somebody's already made a prediction, I can test it because I know the answer.
Yeah, no, I've heard there's a Danish proverb that amongst all the things difficult to predict, the future is the hardest.
That's right. Especially when the future has so many interwoven parts and is chaotic.
My little pet peeve is when people talk about climate science, and I actually think, there's a book called The Death of a Salesman by Arthur Miller, and that was in the 1950s, and I read it dutifully in high school and so forth. And we
turned into the famous play, right?
Yeah, and it got him married to Marilyn Monroe, by the way. through the years, we had drug salesmen come in. Later, they call themselves detail people, but they're always salesmen. And the term seemed to really depress them because they hated being salesmen, because the death of a salesman made the salesman life seem so bad. And so words count. So, I always thought they should rename themselves as information vehicles, I don't know, intellectual carriers and so forth. Because if you were to be fair to them, that what they think they're doing is giving you information and so forth. And information is key to wealth and prosperity and all that kind of stuff. And I'm not saying that they're not biased, whatever, but they're presenting a point of view. So I always think that words matter and how they're presented give a format. Climate science, I think, is the converse. It's actually too generous a term for something that's really climate predictive data analytics. I don't know if you think that's fair or not. A, and B, I have these, I got a mini debating society amongst my peers, not climate, geochemists and so forth, but, knowledgeable people who are really, very much imbued with the fervor and zealous attitude of the climate worthy. But one question I always start with is, what is climate? Could you please define what is climate, and how would I know? See, I understand the NBA and the NFL. At the end of every game, they have a score, and then they figure out who wins, and they have playoffs and all that kind of stuff. At the end of the year, they have the winner. But with climate, so I've asked this question over and over again. So let's stipulate, you're absolutely right that bad stuff's happening. Okay, what are the items? Can you give me like 10 silos of things that will happen so that I can make a bet with you, and we can bet 5-10 years hence whether any of those things happen more likely or less over time, and who's going to measure them and so forth. And I've been really stymied by this. This pretty much is an argument stopper. I asked my good friend, he's got multiple degrees, PhD among them. I say, what is climate? And that pretty much, he says, oh, go look at this. Go check out what the UN says. No, I'm asking you what you think. Anyway, so I got you here. What is climate? And what are the 10, say, silos or 5 upon which we either retroactively or retrospectively could have figured out whether they're right or wrong? And or going forward, what are the things we should be looking out for to see whether this thing is correct or not? Kind of like the NBA.
Yeah. So let's go to the first question. Data analytics. Yes, in terms of the modeling side of climate science, but no, in terms of the people that are out in the field. They've just been hijacked, right, by this field. We used to call them oceanographers, geologists, glaciologists, you name it, sedimentologists. These are all these names, and they've been kind of hijacked into these fields. But those are people out in the field, and they're actually collecting new data, and they're applying proxies, and they're trying to come up with data and models and things like that. There's other people that are just on the computer side, and they really are crunching numbers. They're doing stats. They're but they're trying to pull from the data side. So I think there is a group that is definitely what are data analytical, data analytics essentially. But there's probably both, I would say. If you really go and want to be nitty gritty about it. What is climate? Climate, to me, it depends on the time period that you're defining this term. If you define climate prior to the satellite era, you were talking about long-term variations in patterns of things like temperature, precipitation, humidity, aridity, you name it. Right? Forest cover. So there's tons of different metrics that you can use. And you're looking at long-term variations. Prior to the satellite era, when we were talking about long-term variations, we were usually talking on the minimum resolution of things like millennia, but probably more on the things like tens of thousands to hundreds of thousands of years, usually. Because most proxies, it's really difficult to get very fine grain resolution. So certain things you can have century scale, but most things, to be safe, you're probably talking on the millennia scale in terms of resolution. As the satellite era has come into play, and I think if you Google climate now, Google response is that it is the decadal variation, or the variation on the order of decades in parameters such as temperature, precipitation, cloud cover, you name it, right? We'll talk about some of these metrics here in a minute. And so they've done that because we have, or I mean, nobody's done this, but this has just become kind of the parlance of our times, because we have about 60 to 70 years of good satellite data. So if you could say that climate is really about 2 to 3 decades, well, you have maybe 2 cycles of that. So really it depends, but ultimately the bottom definition, the total definition is usually the same, this long-term variation in these parameters that we maybe would call weather on a daily basis. And the length of that has varied dramatically. How about what you're essentially asking for is a scorecard. You want to be able to score whether or not these things are accurate or not, right? Could you pull up my Twitter? Do you have access to my Twitter?
Absolutely.
If you go onto my Twitter, you'll see that within just today or yesterday, I'm going to pull it up right now, actually, too.
I'm going to put it right in.
Oh, actually, you have to scroll down a little ways.
Okay.
But you'll see that I have a table there. Keep going. Keep going. So this is a lot of articles. If you go to my Twitter, I repost a lot of articles just so people can have access to them instead of having to go there. And it kind of summarizes them. Keep going. And then one more. 2 more. 2 more. And one more. There. Nope. Next one. Okay, one more. There it is. So click on that table right there. So here's a scorecard. So here is a scorecard from, it's a little small, but that's okay.
Yeah, I'll pull it up. I'm going to make
this is a scorecard from the IPCC from AR6. So this is the last report that just came out. This is table 12.12. And so what this shows is what we call climatic impact driven driver type. So, or they call climatic impact driver type. So this is the type of thing that is being affected by what they would consider anthropogenic greenhouse gas emissions. And so in this field, what they show you is things that are going to be related to heat and cold. So that's extreme heat, extreme cold, frost. Things are going to be like high precipitation, low precipitation, droughts, winds, snows, ice, coastal afflictions, relative sea level, and things like that. When you see the boxes there, we're not going to concern ourselves with the numbers right now. The numbers just relate to certain papers, but the box colors are important. So the box colors are related to, if you scroll down all the way to the bottom, how much change there has been. So a dark orange is high confidence of a decrease, and a dark blue is a high confidence of an increase. And notice that a white box or no color is low confidence in the direction of change. Okay, so scroll on up and notice that right now there are only 7 out of 33 boxes that are checked. So the temperature is going up. I think that we can all safely say that that's probably true, and there's a lot of reasons for that. Cities, for sure, that's likely related to the urban heat island effect primarily. But notice how many white boxes there are. There's a white box for marine heat waves. There's a white box for ocean acidity. So let's remind ourselves what that means. So scroll up to the top again. So what that means that any evidence for example, marine heat waves or the mean precipitation or the amount of river floods has not yet emerged in the historical record, even though we have been warming now since essentially 1850 is the claim, and rapidly warming since about 1975. Thus far, since this was published this year, anything that you see in a white box has not yet emerged. And so what you can see is they're really hedging their bets, because look how many white boxes remain even in 2050. That's the next column over, emerging by 2050. So the truth is the IPCC is really not betting on a lot of things changing. They really aren't. It's the media that's taking this stuff and running with it. And even guys like the head of the UN, this Antonio Guterres, that take this information and claim there's a crisis. To me, I see much more white in this. Even if we go to between 2050 and 2100, which is the third column, there's predominantly white boxes. White boxes mean that there is low confidence in the direction of change. We don't even know if it's going to go up or down, let alone can we assign whether it's due to anthropogenic global warming.
Hmm.
So there's such a disconnect between what IPCC is really saying and how they're hedging their bets, and how somehow the media and the climate scientists on Twitter and things like that love to take this information and run with it and call it a crisis and an emergency. To me, I don't see a crisis in that data.
Fair enough. So let me ask you about the actual data. And I apologize. I'm going to interject with more basketball or football information. I'm old enough now. I don't quite count my age in geologic eras, but I'm pretty sure since everything's accelerating, I might actually have been born in the last previous one. But when I look back at the NBA, I started kind of watching it maybe a tiny bit as a kid, but more as an adult. I kind of remember the Magic Johnson era.
Oh
I
yeah.
remember the Michael Jordan era. I remember, I don't know, the current, maybe it's the Steph Curry era. There's small ball. There's centerless basketball. The Magic Johnson era was Showtime, but it could have been the Larry Bird era. Maybe it was the Larry Bird era of kind of finesse passing and 3-point shooting. A lot of this is very subjective, like how you look back at the NBA. And mind you, it's all there. The data are there. People can pull the games back up for the most part and rewatch them. They keep track of data minutely. They do rebounds and this and that. Now they have all this kind of massage data. This is the first person to have 5 rebounds. His name misspelt on his jersey, left-handed on a Tuesday, raining in February. They have incredible, I guess, kind of mining of data, and yet, that didn't tell us who won any particular year. Magic Johnson, I think, won 3 times, maybe 4. Larry Bird won 3 times.
That's right, I think.
But it wasn't even them, because they were parts of teams. There are a lot of great players who didn't win anything because they didn't have the teammates. And so we look back at this, and there's huge data. And again, if you've summed up all the data of the last 5 decades of the NBA, you still couldn't tell who's going to win 5 decades from now. You don't know who's going to be playing. You don't know what, I assume the ball's going to still be round and the rim's going to be circular and all that kind of stuff. And probably gravity's still going to be here. And maybe we'll have the same, atmospheric thing. And, who knows? But where are they going to be playing against? Going to have, maybe they'll have a stadium in Mars. I have no idea. But the fact of the matter is, you can look at a lot of this stuff and you can have all the data you want, and it's somewhat predictive. I think people use this to make up teams and whatnot, but it still comes down to a lot of anomalies that, frankly, there are fewer data points and fewer actors within the realm of the NBA than there are in the atmosphere.
Oh, absolutely.
And
absolutely.
So I always find this a problem, like how you're picking the data. And I had Dick Lindzen on my local Newton show I mentioned to you earlier, Professor Richard Lindzen, formerly of MIT. And, he disputes some of the actual, if GIGO, garbage in, garbage out, he refutes some of the actual warming numbers. And you mentioned heat islands, and I think there's some kind of like data problems with selection bias of how the weather stations are placed, whether they are urban versus not. On my own particular golf course, there is a weather measuring station, and this golf course is all green and trees and whatnot. Where do they have this thing? They have this thing next to the pile of gravel and sand and a driveway near the mechanics access. It is literally the hottest spot in the entire golf course because there's piles of rocks and they're whitish colored, and they're not whitish, they're black and asphalt and so forth. And it's a hot spot right there. There's no moisture, but that's how things get measured. So I don't know how factual all this stuff is. How well can we tell, leaving aside today's measurements where we have sensors and whatnot, how well can we tell the carbon dioxide level from 50 million years ago, and so forth? And where do these debates go? Is this all kind of like kind of pedantically, self-referential?
A lot of it is, absolutely. I mean, a lot of it really is. In terms of like the placing of the weather stations, of course, they're in places that are easy accessible. These things need to be cleaned and they need to have power. And so, they're always placed in places that, someone can get to them. And that usually is a place that ends up, being surrounded by more and more buildings, because, for example, it used to be the little Podunk airport, right, that had just prop planes that were taking off. And now there's 6, half-mile long runways and jet engines everywhere. And you see reports of, oh, this airport sets a new temperature record. And I was like, oh, yeah, well, that kind of makes sense to me. I mean, we are changing the landscape. And as we change the landscape, we do change how the sun interacts with the surface. I mean, if you've ever walked barefoot on grass and then stepped on the asphalt, on the blacktop, that there's a difference. And so those things trap heat and they re-radiate it at night. And it's interesting because when we talk about temperature change, what we normally see, or what we predominantly see, is we're not seeing a ton of increases in the high temperatures. But what we tend to see is that there's an increase in the overnight lows. And so that's a real interesting thing. So if you take that and you homogenize it into a global average temperature, that's driving the temperature up because the average is higher if the lows don't go as low. And most of the cities, when we see that, that's clearly the urban heat island effect. That's the heat capacity of things like asphalt and glass. That's significantly higher than, for example, dirt and rock and grass and trees and things like that. And so that heat capacity means it can retain more heat, and it radiates more heat throughout the night, and the night doesn't reach that super low temperature. And so we're really not breaking a lot of records. I mean, occasionally we do, but in terms of high temperatures, we did recently in Texas and a few places. But if you noticed, a lot of those records that were being broken are from the 30s. And so it's really interesting, how the temperature is actually changing. But, the ultimate idea is, should we expect stasis? Is our expectation, is the null hypothesis that there should be no change? And if there is any change, it is attributable to humans. Because if that's the null hypothesis, then clearly the geologic record doesn't support that, because that would suggest that if I look at the geologic record, then things should be flat and there should be essentially no change before humans arrived. But that's not what we see at all. We see dramatic changes in temperature. We see dramatic changes in CO2. CO2 was over 5,000 ppm at times. In fact, the time period where the plants on the planet were the most successful was the Carboniferous. That's a time period where CO2 was on the order of 12 to 1,400 ppm. And so, what is this kind of optimum that we're trying to protect? What is the null hypothesis? Is the null hypothesis that there should be no change? Is that, and if that's the null hypothesis, I think that we're already starting off wrong by measuring every little change.
I know what it is. Could you define for our audience null hypothesis?
So that's essentially just, what is the starting point for that there is no effect, right? So if we're not having an effect, then what should the answer be essentially? Right. And so if the answer should be, if we're not having an effect, then nothing should be changing, we're already starting incorrectly, because that's just not what history shows us. Long before humans existed, dramatic changes occurred on the planet in terms of climate. And so that's already an invalid null hypothesis, because if you make that null hypothesis, then anything that you observe that's changing, you automatically attribute to humans, to anthropogenic change. Right. But if your null hypothesis is that there is significant natural variability, for example, Dr. Judith Curry likes to argue that if you actually propagate errors in climate models and understand kind of all of the variability, remember that. So I talk about this on the Substack too. If you have peaks, right, and they're right next to each other, two distinct peaks. Well, one way to minimize those peaks is to essentially average between them, right? And if you average between those peaks, you kind of smooth between two distinct peaks. What happens in a lot of our proxy data when we go back in time and try to figure out what the climate was is we plot that on the x-axis is time, and then on the y-axis will be whatever metric we're looking at, past CO2 or past temperature. Well, what happens is that on our x-axis, our time axis, there is a lot of variation because it's difficult for us to pinpoint exactly what time period we're looking at. So what that does is it smooths the data, and you miss the little resolution, the high resolution variation that you would get, for example, if you're doing real-time measurements like you are today, right? So today we have real-time measurements that are by the second with satellites. So one way to get away from the urban heat island effect is go with satellites.
Right. And
right?
also,
So
isn't there kind of an average? Professor Lindsay talks about the average temperature of the oceans and so forth. Is that discussed at all?
yeah, I mean, it's a number. I think it's meaningless. I would argue it's about the same, has about the same meaning as the average phone number in the phone book. It's probably not a number that if you dialed would call anybody, but there is that it exists. Somebody could actually go through and average all the numbers in the phone book. Now you actually have that data. The problem with averaging all the numbers in the ocean is that we measure something like 0.0000001% of the actual ocean, and then we extrapolate or actually interpolate depending on what where you are, between buoys or between measurements between ships. So there's 99% of it is guesswork with a few measurements here and there. But what's the meaning of that number? What's the meaning of an average global temperature? Nobody lives at the average global temperature. What's that meaning? If you're in a region that is cooling, there's certain regions that have actually cooled significantly, and everybody's talking about global warming, you're not going to care, right? But if you're in a region that's significantly warmer, but other places, so it's just it's a real simplistic reductionist way to take a real complex system and reduce it to a single metric. But I understand why people do it, because it's easy to talk about. I don't think it has a lot of scientific value.
So I was on, I don't know I think his name is Patrick Moore. Let's see if I have this right.
Patrick Moore from Greenpeace.
And he posted this. This is geologic time.
Yep.
And I said, have at it. The first graph is anti-man-made apocalyptic climate change. We're all going to die. Yeah. Oh my God, CO2. That's my hashtag here. The second two are pro. I've just asked people, can they go over these? The second one's a little bit more complicated. So I don't know if we're going to really get it, but this is from a pro, we're going to die climate change kind of advocate. And this is from a reformed Greenpeace guy who says, well, let's look at the big historic picture. And I'm not sure where he got this thing, so I don't see any attribution to it. And so somebody says this is Moore's graph is an unpublished fake by Nutty Ned Nikoloff, and this guy over here on the lower right. And here's a link for the other two graphs. But the question, so I'm going to,
they're very similar. The truth is, I mean, so the problem is that the second graph right here, what they're doing is they're changing the x-axis along the bottom, and that's good because we have much more data on the short term. But the truth is those plots match identically. Right. What they're arguing here is that. So what Patrick Moore and I will argue is that there's significant times in the past geologic history where atmospheric CO2 and temperature go in opposite directions, essentially.
Right. So this one here, just for our audience at home, this is atmospheric CO2. Is this the same time scale? I don't think so.
Yes.
No, this one here is, let's see,
60 million years
before present, 60. Yeah. And here, this is...
it does it too. 6 on the left-hand side, 60. See how it breaks? The time scale breaks into chunks.
Okay, fine.
That's why it expands
so they're saying here the CO2 level's high over here.
That's right.
Therefore,
and temperature was high.
That's right. Although this is correlation, not causation. Then it's down, and it's down, and then here we are. So you are here basically, and then this is what's going to happen. So the part that I have an issue with, is that all the predictions go up, and they go up, upper, or uppest. They only go this direction, and this is the part that you're extrapolating this. This is where we have to change all our behaviors and get rid of society and live in caves or something like that because of these predictions. And I'm not sure this is really factual. So can you address?
So I think I wouldn't say it's, so I think the predictions can't be factual because they're unscientific, right? So it's untestable, it's unfalsifiable. So a prediction by its very nature is doesn't fit. It doesn't fit in the scientific method. But I think it's important to state because, so much of this has become essentially modeling and future predictions, and that's the science. And I'm like, well, that doesn't even actually fit the scientific method because I can't test it. But I think it's true. I think it's factual that in certain time periods, CO2 and temperature correlate quite well. And I think we know exactly why that is. So the vast majority of the CO2 reservoir that exists on Earth is in the oceans. And it is in the deep ocean predominantly. The surface oceans have a little bit. The surface oceans and the atmosphere is pretty similar in terms of their total amount of CO2. And the deep ocean has many orders of magnitude more than that, on the order of hundreds, if not thousands of times more, multiple thousands of times more CO2 in the deep ocean. And so when temperature varies on the planet for lots of different reasons, for example, orbital cycles or possibly a volcanic eruption, what we see is that the surface waters respond pretty quickly, but it takes a long time for the deep water to respond. And so as, for example, temperatures warm, we see the atmospheric temperatures warm, and then we see there's a lag period, and then the ocean temperatures start to warm. And as the deep ocean starts to warm, it starts to release CO2 because of what was known as Henry's law. Henry's law essentially states that the amount of a gas dissolved in a liquid is proportional to the temperature of that liquid. And as you raise the temperature of that liquid, the gas leaves. Leave your soda.
I've seen this when they open a Coca-Cola can.
Yeah, exactly. Leave your soda open on a hot day, and it goes flat way quicker than it does on a really cold day.
And plus, when you open it, if you have a hot can, it's going to.
That's right.
Burst with the warmth. If you keep the can cold, the CO2 stays dissolved.
That's right. And so it makes sense that as temperature changes, CO2 lags behind and also changes. And we see that with the ice cores as well. But we also see lots of time periods, for example, where there was large glacial periods where we have very high CO2. So the Ordovician-Silurian glaciation, this is a glacial period that happened somewhere on the order of 430 million years ago. That was a time period where CO2 was in the 2000 ppm range. So out of the big 4 glacial periods, not the little glaciations that we talk about, we're in the last glacial period right now, but we kind of group those together. So when we're in these big kind of glacial periods, the Earth oscillates in and out of glacial and interglacials. But out of the 4 of them, 3 occurred at elevated CO2 levels, and only 1, the last one that we're in currently, occurred at lower CO2 levels. And so what this means is that it doesn't mean that CO2 has no effect. It just means that there are so many other climatic effects that overprint on top of CO2 that even CO2 at the 2000 to 3000 ppm range still permits the planet to go into a glacial period where, you have a kilometer of ice on top of New York City. So it just highlights the insensitivity of the surface temperature to the amount of CO2 in the atmosphere. It doesn't negate the fact that CO2 has an effect. It just highlights the idea that the atmosphere is relatively insensitive to the amount of CO2 in it. And so all the changes that we observe are much more likely natural variability attributable to lots of other things that we still are scratching the surface in understanding as compared to the rise in anthropogenic emissions.
Thank you. So there's a lot there to dissect. I'm not going to be able to do it in real time right this second. One question is, how do we tell the CO2 level 50 million years ago?
So 50 million years ago, it's getting tough. And so the truth is the error bars are getting big. But this is all done through proxy data. So when you're getting back into that time period, you're essentially going to be using fossils and paleosols, ancient soils. So you have a pretty big variation in your x-axis. You're going to be 50 million plus or minus 3 million years maybe for your time period. And you have a pretty big variation in whether this was a closed system, did these things interact, has this isotopic signature changed? So, there's going to be a lot of assumptions that go into that. So the errors get big. Proxy data is really good at telling you how relative things were changing. So, look, 50 million years ago, it was warmer than it was 60 million years ago, or it was cooler than it was. But it's really difficult to say, 50 million years ago, the surface temperature was 15.7 degrees Celsius.
Alternatively, we could ask Dianne Feinstein if she remembers.
I think her kids just took over power of attorney.
Yeah, so there are very few people. Have you ever seen that interviewer Philomena Kunk? She's a parody.
No.
She asks these kind of hysterical questions. I'm going to leave that aside. Anyway, so what's top of mind right now for you? What's the thing you're hoping to, if you're, St. George and the dragon, how are you hoping to slay the dragon? Who is the dragon? Um, um, what's the way forward? What do you see as the reasonable equilibration? You were mentioning a 60-year-old Greta Thunberg, what she might think. I don't personally think she's capable necessarily of having her mind changed.
No, probably not yet.
You were being optimistic. I'm not even sure it's 60, but you were optimistic about it. So what's the lay of the land? What's happening? What are the things we should worry about? Are we being hoodwinked? Are we being? What are the dangers? Let's say they're all right, they're all correct about it, and let's stipulate a few different possibilities. What should we be doing? Should we just bow down to our climate overlords? Tell us.
So there's a lot there. There's a lot of questions there. Let's go with what I think is the right answer. Well, first of all, so the biggest problem that I see, the dragon that I have to slay, is what I think is the bastardization of science. This is the politicization, the bastardization of science, using science and trying to push policy with it, even at the expense of having to essentially cherry pick data or omit certain data or push editors to not publish things or retract papers such that you can build what I would consider an artificial consensus so you can drive policy. And what that does is that really doesn't open the door for discussion. And when you can't open the door for discussion, you make a lot of stupid mistakes. And humans just have done this in the past, and I don't want to see us repeating it. We did it during COVID. Anytime we're in a crisis mode or emergency mode, we tend not to respond or react very well. Mm-hmm. So that's the dragon to me, that we're not in crisis or in emergency mode. And if the science clearly backs it up, even the IPCC, the table we looked at, I mean, they're more than open about the vast majority of the things are not being affected currently. So if we can slay that dragon, I think we can ease anxiety. How do we, is there a problem at all? Yeah, I think there's a problem. I think that fossil fuels are finite. So a lot of people push back and say fossil fuels can be created naturally and abiotically. That's true. I write about it on my Substack. Check it out. But still, all evidence points to the fact that the hydrocarbons that we're using today are from fossils. They have a light isotopic signature. They're found amongst other living buggers. So we're just pretty sure that they're from fossils. Doesn't mean that there aren't abiotic ways to make hydrocarbons. And so they're finite because we're using them much faster than they're developed. There's geopolitical arguments that can be made. So here's the answer to me. So let's shift our electricity production to nuclear and gas, natural gas. We're still going to have to use probably about 20 or 30% of the natural gas for the Haber-Bosch process, which is the process that makes synthetic fertilizer, because about half the world's population is now essentially supported by the fact that we make synthetic fertilizer, ammonia, essentially, and so nitrogen, and that comes directly from methane. So we're going to have to use some of the natural gas for that, but we can continue making electricity with natural gas and then predominantly with nuclear. We take all coal and oil offline, and then we continue to use oil for the vast majority of the products that it's made. So remember, something like 50% of a barrel of oil goes to other products besides petrol and gasoline. And so we'll continue that for transportation. We'll scrap all these wind farms and solar farms. Solar on your house, no problem. I think that's a good idea. It could reduce your bill. But nuclear is so cheap once it's built out that the incentive probably wouldn't be there. So you'd essentially drive away all of the heaps of rusted metal that will be rotting on the eastern seaboard soon. Yeah, you pulled up the graphic. So this is something I ask people all the time. They just stop oil all over the place. I say, I understand that you don't want to burn oil for electricity. And maybe you're right. Maybe that's an honest argument. And because we do have things like nuclear power, maybe we shouldn't be burning oil. And the fact is oil is so useful for so many other things that maybe it is stupid to be burning it for electricity. And so let's use it for all these other things.
You could always recreate oil. All these things are fungible essentially.
If you have enough energy.
You have enough energy, you can um, you can do what you like.
That's
And
right.
so, I mean, my own personal feeling, I'm sorry to divert you, but my own personal feelings, people want to get rid of fossil fuel. Well, guess what? If you did, it's like getting rid of heroin and getting rid of cocaine. You think you can outlaw, but it doesn't get rid of it. There just becomes a black market in it. And the fact is that it's energy dense, it's portable, it's really super cool. You can quote unquote charge your car for 400 miles or 300 miles in less than 3 minutes with pumping gas. Now, if there are no gas stations, it might be harder. But the fact of the matter is, the stuff exists, and you're going to be able to make energy and electricity out of it.
It's not a coincidence that Earth scientists started using this material. So in my class, I go to the rec center and I would videotape of somebody on the rec bike, and we would hook up a little thing to show how much power they're producing. And I'd show them in class that, that person would have to pedal essentially nonstop for something like 8 years to produce the amount of energy that 1 barrel of oil produces. So it's no coincidence that we're using this material. This material is essentially, was what's driven human, flourishing. It's the whole reason that we had the revolution that we've had.
Actually, speaking of Greenpeace, they wanted to save the whales. Well, what did save the whales is Rockefeller finding oil in Pennsylvania. Before that, they were lighting the cities with whale oil. They were catching the whales not because they were delicious. I'm not sure they were. They were catching the whales because they had oil. And so they were a dense, piece of, basically bacon fat, but whale fat, floating around, with a mouth at one end and a butt at the other.
That's right.
Being whales. And they were lighting your cities.
That's right.
And, lighting cities actually has a positive benefit. When you light a city, you have better commerce, less crime, fewer rapes, all this kind of stuff. And so it's good to light a city. You can argue that we shouldn't do any of this stuff, that we should just live in caves, but then there's not going to be like 7 billion people or 8 billion people on the planet.
Well, this is
maybe going to go back to 90,000, whatever that was, in Africa, as you point out in your kind of time silo.
This is the Malthusian part, right? This is the Malthusian side of this whole argument. This climate side of the argument has kind of become a catch-all. It's an umbrella for essentially socialism and central planning. And then it's also an umbrella for essentially just poverty. Like if it's true, if we went back to caves, we would have a lower impact on the environment. It's true. But do we want to do that? Yeah. So this is a paper that was just published August 30th in the journal Science. And they did a genetic study where they looked at how the human population has changed. And notice they have this 0.9 MA event on the left-hand side. That's the 900,000 year event that they're talking about. So this was a time period. Yeah, right there. This was a time period.
This is just for the argument. This is kiloyears.
That's right.
Not to kill you, but thousands of years.
That's right. So that's a million right there. So that's 900,000
years ago.
That's right. So 900,000 years ago. So, Homo sapiens are around. And at that time period, we went down to 1,280 individuals, fewer than 1,280 individuals.
So bottleneck.
Yes, that's a remarkably small amount of people.
It's right here. This is little hourglass.
That's right.
So you have 100,000 individuals here. We went down to like nobody.
That's right. And if you think about what's happening in terms of the climate, that's a remarkably cold period. That's right. The recovery happens, and then we have the real explosion as we disperse out of Africa.
Okay, so why do we go down to this?
So if you zoom,
how do we know this? A, how do we know this? And B?
So this is a genetic study. So they do this through modeling through genetic studies of certain certain chromosomes. And so, I didn't go into that part too much. And I used to be, actually, my original degree is biochemistry and cellular biology. My first job was growing E. coli and splicing out certain segments of their DNA because we were trying to come up with a HPV and an HIV vaccine. When I was at UCSD, they called it Biotech Beach. But I didn't go into it too much. But, these studies are pretty common. People have been doing these kind of genetic tracing studies. But I can't speak to the fundamental as if they did anything fundamentally wrong. But what's interesting is what I found interesting was if I take it at face value, well, what was happening at the climate 900,000 years ago? Well, that was a glacial period. That was a time period where we entered another one of these glacial periods. And
so you're saying it was at that time was, if I get the word correctly, it was cold.
That's right. Exactly. And we can see this over and over and over again, that when we go into these glacial periods, that this is a huge strain on the human population. And I wrote an article that what is the climate optimum? And why are we protecting this climate? Because this climate has shown in the past to almost cause our extinction. The climate just 1 million years ago or 2 million years ago was not this unstable. We didn't have this oscillation between glacial and interglacials. If we're protecting this climate, we need to be ready for a kilometer of ice on top of New York City, because it's going to happen again. So why are we protecting this, what we think is this optimal climate? It's just weird to me that somehow this has become the optimal climate, where the evidence is just clear. There's so much evidence that we're going to go into another glacial, and maybe, just maybe, if it's true that greenhouse gases are really driving warming, we could have accidentally saved human civilization.
Well, that's a good day's work.
I mean, you know, if it's in fact the case, I don't think that CO2 has enough of an effect. That's why even the IPCC includes so many of these feedback loops.
So,
because,
when people go nuts over the climate stuff, and I get called names and whatnot, I get called names over COVID. I get called names over climate. It's really, I don't know. Maybe those are good names. But I always say, can you tell me what percentage of the atmosphere is carbon dioxide? Because you've been using ppm, and 1,000 ppm and so forth. It sounds like a lot, but what, so I always ask people, what percentage of the atmosphere is carbon dioxide? And most of them will say, 5%, 4%, something like that.
It's only 2 orders of magnitude off.
Yeah, so it's 0.04%.
That's correct.
These things matter. Like, if you ask people what percentage of people died from COVID, you'll get almost the same thing. The Democrat kind of, or left, say, of center people, during COVID, they were polled, what's the death rate from COVID? And their approximations were, I think, 15 to 20 times higher than Republicans' approximation, which was the accurate one, which was, it was like, obviously it depends which population you're looking at, what age group and whatever, but across all of humanity, it was, 99.7% of people with, kind of like symptomatic COVID survived. And the Democrats thought it was like, much like 10, 20 times worse than that. But
who knows how many asymptomatic people there were as well. So that number would actually
I think there's I think there's actually a category error there. I mean, we're not here to talk about COVID, but science, we're talking about science in general. Omicron is not genomically related to SARS-CoV-2 or SARS-CoV-1 for that matter. It's a sui generis, spontaneous, coronavirus that popped up in Southern Africa, not South Africa, Southwest Africa someplace. And we've always had coronaviruses. They've always been around. They've always, so once we were able to figure this stuff out, in the 60s and whatnot, it turns out to be the second most common named cause of the common cold, coronavirus. So the fact that Omicron shows up positive on a COVID test when it's not really a SARS-CoV-2 is a problem with the coronavirus test. It's undersensitive, not specific enough.
So that would inflate numbers essentially.
And so what we're seeing is, the fact of the matter is that a lot of people just happen to have coronaviruses because coronaviruses have been doing that forever.
Yeah, they've had it before.
And we've been miscategorizing them as, now we call it Omicron. Oh my God, we got Omicron, XBB 0.525, whatever it is.
Whatever it is now, yeah.
Dude, you have the common cold. And I have to tell those people over and over and over again. And anyway, I have an article on that. I might pop it up here just so people can find it. But we're going to be rounding out the hour. And before I give my own shameless self-promotion, tell us what you'd like to leave people with, what concepts and thoughts.
One thing that a recent study came out with was that the more you know about climate change and about these studies, the less anxious you are about it, And so I just encourage people to go actually read some things. Don't just listen to the headlines. Don't read the headlines from just The Guardian and things like that, because they're really pushing just the most extravagant stuff. And I show that a lot of the newsworthy material that they pick doesn't end up being true, but it's just the most sensational, and
I think
it gets the most clicks.
The emphasis in newsworthy is news, and the fact who's running the news. And I used to think the news was news, but I'm actually closely related to a journalist got a master's in journalism from. Anyway, he told me at one point that I was totally mistaken about, and I was naively idiotic about what the news is. He said the news is not about reporting; the news is about pushing a narrative. And anyway, that's a totally separate thing. And oftentimes, I think people forget that, and they just hear things and they assume it's true. So I'm going to close out, and let as we kind of round out. This is my article from a year ago, which I thought would be the final word on this. It's in the Daily Skeptic. I couldn't get it in any of the major news outlets and so forth. But is it time to accept that Omicron is not COVID-19? It's not. It's never. It hasn't been. And I go on to this is kind of a genomic map. Omicron is really, if you wanted to talk about planets, let's say ancestral is Earth. This is kind of like
Mars. I can't see it.
Oh, you cannot see it? I apologize. Oh, I didn't put it up. I'm so sorry.
There anyway, we go.
This is my article on is it time to accept that Omicron is not COVID-19? Right. It's in the Daily Skeptic. That's a coronavirus right there. Thank you for pointing that out. So the ancestral SARS-CoV-2, not even CoV-1, but this 2019 version is over here, and the number of mutations away. The alpha
50
alpha
mutations away.
This is the number of mutations. This is from a journal 2021.
Crazy.
I'm not getting into this too much, but Omicron is far distant from even the alpha, beta, delta, gamma, lambda strains, kappa, and all that kind of stuff. So the ones that we worried about, alpha and beta and delta, maybe, are over here. They've actually self-attenuated in as these things, if they don't have an animal host to go back to an animal sanctuary, they become common colds because they can't succeed in a population base if they kill us. So even if they get you very sick, they don't transmit. So either you basically have to exchange transmissibility for lack of danger. So the more transmissible you get, the less dangerous they are. Omicron's fine as far as transmissibility. It's not dangerous, and it's not related. It's more in the common cold range. And this is like from nextstrain.org. This is Omicron over here, and it's actually not closely related to the nexus.
Oh wow, yeah.
Of these other ones. So it's not. It's basically a whole thing, a category. And as far as the danger, Omicron's way down here about danger from original SARS-CoV-2. This is an order of magnitude more, 20, 30 times less dangerous.
Is Omicron what they're talking about for the most recent?
Oh my God, it's been ever since the end of 2020. It's been Omicron. It's almost 2 years of Omicron. And coronavirus has always been. This is from textbook 1999. It's always been the second most common named cause of common cold. Rhinovirus number 1, coronavirus number 2.
And then look at the unknowns. Yeah, big unknown.
And these are influenza Bs. This is not influenza. That's not the major influenza. These are influenza B. It's a whole bunch of them, but who cares? We shouldn't be testing. We should stop testing all this stuff. And I go on to about 10, 12 reasons why we should do this and how important it is. And a lot of this has been, to keep the emergency under EUA so they could get the bivalent
the
vaccine
Authorization Act, right? That's the Emergency Authorization Act.
Yes, exactly. And the bivalent vaccine, which is in the current one, the last 2 versions of quote unquote booster, is doubly pointless because part of it is for SARS-CoV-2, which does not exist anywhere in humanity. And the other part is for this Omicron, which we've never really immunized against common colds. So it's got one part that's totally an anachronism and the other part that's pointless. Anyway, so that's my little bit on Omicron, in case anybody's curious about that.
But you make I think there's a lot of connections between how we responded to COVID and how we kind of how the science was kind of manipulated a little bit, and then how what we're doing with climate. But climate will be the never-ending pandemic, right? Because pandemics will come and go, but climate, the climate's going to continue to change, and it's become this more an umbrella to reduce freedoms and harness more power into central government, which has never been a good idea.
I think it's all diversionary. My understanding is you grew up in East Europe. Were you born before the fall of the wall?
Yep. So the day we were leaving, martial law was imposed in Poland. So we had to sneak out, and we left all our belongings and everything. My parents just brought me the suitcase that my mom had. We had 2 suitcases. So my brother has one of them and I have another. My mom didn't know we weren't going back. My dad had to tell her when she got here. He said, "You're not going back." And so it was, that's some of my. It's hard for me to remember. I was 4 years old, but I got all the stories as I was growing up. I knew we couldn't go back and see my grandparents. I didn't know why, until the wall fell, until essentially the Iron Curtain fell in '89 and Lech Wałęsa was elected. we didn't go back. So.
Well, not that I yearn for those times, but I think it's, people kind of need a chew toy. They need something upon which to fight. And it wasn't better than to have a Cold War, so forth. But people had existential worries, and in the absence of, frankly, it's kind of what I actually. It's not quite the same thing, but I have a book I've written, I haven't put out yet, on cancer, and one of the terms I think I've coined is that it's a disease of success. It basically, to worry about cancer. I mean, nobody wants cancer. Don't get me wrong.
We live too long.
Yeah, exactly. That we live far longer. The Egyptians didn't worry about, the ancient Egyptians didn't worry about cancer. Not even, frankly, a lot of the modern Egyptians don't worry about it either. And frankly, most of Africa does not worry about cancer.
That's right.
Sub-Saharan Africa, aside from South Africa, the country, doesn't worry about, they would love to be, I mean, not that I don't want to sound fatuous here, but they would almost love to worry about cancer, because that would mean that their median
absolutely
life expectancy had gone from 60 to 80. And so we're not going to live infinitely. And when you live long enough, something's going to get you. If it's not falling down the stairs, because you're half blind, it's going to be a cancer, because they just, your cells have gotten tired and they've worn out. Now, it's always tragic when it's a 4-year-old or a 12-year-old or a 30-year-old. I get that. But those are the rarities. And the mass of cancer, the numbers and so forth, are as we become superannuated. Anyway.
So you're absolutely right, though. I call it first world problem.
Exactly. So climate has become that. It's this thing. It's a fanciful. I think it's it's a slight spectrum shift, like a Doppler shift from real religion.
I wonder what the 2.1 billion people on the planet that don't have access to clean drinking water think when they see these kids in Western countries gluing themselves to things and saying they're victims of, with Starbucks in their one hand and glued to a painting in the other, saying they're victims of a future climate.
With the cell phone.
Yes. Yeah. I wonder what they think. I would think they would love to be concerned about what the climate would be in 2100, but they have to go get food and water and shelter for the day.
Stuff. Yeah, not kind of. I assume you've heard that Konstantin Kisin.
Yes, absolutely.
Yeah, so he talks about, frankly, how Britain has outsourced its CO2 emissions and so forth.
I wrote about it on the Substack. The Western world has reduced emissions by 20 or 30%. Global emissions keep going up. Why? We're just offshoring them to India and China. It's real simple. And then we pat ourselves on the back.
I totally agree with you about the nuclear part. And I always get a laugh. I was with a PhD physics friend of mine. It was unfortunate circumstance of a funeral, not his or mine as of yet, but he's an expert on a number of things. But one of those is people always want hydrogen. They want hydrogen cells, and he was pointing out that hydrogen, is not atomic; it's molecular hydrogen, and as such, it actually gets to be smaller than atomic hydrogen, because the kind of the electron, they kind of bonds everything tighter. It's a tighter set. It's more stable than singular hydrogen, and it's so tiny that you can't keep it in a flask. I mean, you can for a bit, but there's no way to prevent hydrogen leaking, and so it becomes an inefficient thing. If you think you're going to have, like I have my propane tank outside from, and pretty much turn it on wherever you can leave a year, so forth. We have propane, but if you have a hydrogen tank, there's none of the valves can be made tight enough to keep hydrogen from leaking out, because it's easy. This is a technical term. I'm not sure you've heard this in your biochemistry. It's eensy weensy teensy.
That's right. I think that is the technical scientific term. But yeah, absolutely. So when I work on these big mass spectrometers to do isotope geochemistry, we have to have a huge amount of vacuum, because we can't have anything to get in the way of the path of these little atoms that are flying through this machine. And the path length is really long. So we have to get an enormous vacuum. What we do is we have to bake the instrument. We literally wrap it in heating tape, and then we heat it. And that's just to let the water come off of the walls, the water that's stuck to the walls. And we don't even think about the hydrogen. We know that the pumps would never be able to even pump the hydrogen. So we just accept the fact, and these are $3 million machines, and we still accept the fact that we're going to have hydrogen in the system. We just can't, there's no stopping it. And so if you don't want even a $3 million instrument, some of the most fancy mass spectrometers, we essentially just accept that our valves will not stop hydrogen. Hydrogen is the biggest, the amount of water it takes for it just to do this. It is crazy, these ideas that people are coming up with. And this is some of these, we're making solutions to problems we don't have.
It's outsourcing the pollution. If you had your hydrogen burner downstairs, which mind you might cause a huge fire because it's highly combustible. You know, all you did, again, like the Keystone analogies, you've outsourced your fuel consumption until you go nuclear. You're just going to be burning, stuff, whatever. He actually had one other excellent point, which he saw in the movie Oppenheimer, which I have not.
I have not either.
But he had trouble with. He says basically two movies. You know, there's the bomb, and then there's the trial. But he said at one point they had a worry that if they had a nuclear bomb, that it might set the atmosphere on fire. And he was like, and I haven't validated the part of the movie. I haven't seen it. I don't know the context. But he was like, huh? What? There are scientists saying this? Like, what? How's the atmosphere going to go on fire? Why doesn't it go on fire when there's lightning? What's the catch on fire?
Yeah. What's
the
combusting?
Is nitrogen. It's nitrogen and oxygen. Yeah. Oxygen can't go on fire. That's the thing that you make fires with. Nitrogen is obviously not combustible.
Inert. Yeah.
And so what else do you have there? What's going to go? The clouds are made of water.
1% argon, maybe.
What are you going to put?
That's not flammable.
Argon's a totally
a noble gas. Yeah.
So what's going to go on fire? The birds.
Nothing.
Like the birds, mosquitoes and birds. Like, what do you have up there? Anyway, right. so that was kind of the movie where he got divorced. But this is science-ish movie, and it's like, I don't know.
Yeah, there's a lot of weird bastardizing of science in the movies too.
Yeah, fortunately we didn't do any of that. But just to kind of get back to my little gripe with science, and again, if you want to help support my video cast, you can send Matthew some money, and he'll give me a cut. But more particularly, I do have I don't have a the Patreon or whatever, but I do have this book out, which I like people to read. It's called Overturning Zika, the Pandemic That Never Was. That's somewhat self-explanatory. The book comes with a picture of me on the cover right here. But this is an amazing, I think this is an amazing thing. I wrote it, I know that, but I'm not a Zika expert. I'm not an infectious disease guy. I'm not a tropical disease. I've never been to Brazil, so forth. But I was just stunned when I came upon this initially, but then in 2019, I was nudged by Facebook about a post I'd written in 2016 that I was quizzical that Zika might not be doing this. And I had not found no instances of microcephaly increase ever since. And I thought somebody would be writing about that, but nobody had. And so I took it upon myself to do that. I had an audience with the two editors of JAMA in early 2020, Doctors Bauschner's and Livingston, I presume. And Livingston thought my article was great, good, I don't know. And he was willing to publish it. He was excited about it. But then he said and I was really happy. And then he said he wouldn't because this coronavirus thing was coming around the corner. He didn't want to sow any doubt in the public health establishment at this crucial time. And I'm like, well, I don't know what it has to do with the other. I mean, if mine is good science, you should publish it.
That would be the ideal point to put it out so that the public knows not to overreact.
So you might think. Anyway, there you have it. I very much appreciate your time. People can find you on Twitter. I think I put that up a little while ago, but I'll just do it again. Oops, this is. Let me see if I can.
That's the best place to follow me at Matthew Wielicki there, and then that has access to my Substack and things like that. So
let me see if I don't know if I have it up here. Do I? No, not yet. So here it is. And people, if they have trouble spelling your name, they can find it here and practice and so forth. And
if you search climate denier, you'll probably find me.
Yeah, and if they want to send you food in prison, I mean, what
that's right. Rikers Island.
All right. Well, thank you so much. You and I can talk for a little bit. We're going to say goodbye to everybody else.